Today, we're going to follow on from our previous two Kerberos Authentication sessions and look at some more advanced topics. If you have not reviewed the previous two sessions, I strongly suggest you view those first. In this session, we will examine Kerberos Delegation and Kerberos Cross-Realm Authentication. I'm Stuart Rogers with SAS, and this is the Technical Insights and Expertise series. The first advanced case we will consider is that of Kerberos Delegation or forwarding. In an Active Directory Microsoft world, this technology is referred to as delegation, whilst MIT Kerberos refers to forwarding authentication. The principle with this setup is that the service the end user wants to authenticate to is going to reuse the end user's credentials to connect on to a second service. An example of this setup would be using Kerberos to authenticate to the SAS middle tier and having your credentials forwarded onto the server tier to start a workspace server using Kerberos. This requires that the first service in Active Directory terminology is trusted for delegation. So, in this case, as before, we have the KDC running the authentication service and ticket granting service, the client machine with the end user, and the first server running a service. But now we introduce a second server running a second service. We want to have our end user credentials propagated from the first service onto the second service. The initial authentication of the end user has already taken place. If you want to review that process, please have a look at our last session. The first step is similar to when we authenticated to a service previously. The Kerberos client constructs the KRB TGS request, including the end user's ticket granting ticket, B, and an authenticator, A. The ticket granting service running on the KDC takes its own long-term key and uses this to decrypt the TGT, B, sent by the client. This allows the ticket granting service to extract the ticket granting service session key. The TGS session key is then used to decrypt the authenticator and validate the end user. The ticket granting service then builds the KRB TGS response containing both the service ticket D and a service session key encrypted with the TGS session key shown as C. This service ticket and the service session key are both for the first service. When the client receives the KRB TGS response, it takes the encrypted service session key, shown as C in the diagram, and decrypts this using the client's version of the ticket granting service session key. This gives the client access to the service session key for the first service. Now, the client sends a second KRB TGS request. In this second request, the client requests a forwardable ticket granting ticket from the ticket granting service. The second request, like the first, contains the TGT, shown as B, and another authenticator, shown again as A. Just like with the first KRB TGS request, the ticket granting service uses its long-term key to decrypt the session key from the ticket granting ticket. Then it uses the session key to decrypt the authenticator and so validate the user. The response the ticket granting service sends to the second KRB TGS request is slightly different. This response, shown as step 9, contains a new second ticket granting service session key encrypted with the first ticket granting service session key, shown as E. And a forwarded ticket granting ticket F, which contains the second ticket granting service session key. When the client receives the second KRB TGS response, it takes the encrypted second TGS session key, shown as E, and decrypts it with the first session key it already has. So now the client has access to both the ticket granting service session keys and the two ticket granting tickets, the original TGT and the forwarded TGT. Now, in step 11, the client connects to the service with a KRB AP request. Remember, this is most likely wrapped inside the protocol used to connect to the service, such as GSS API. In this request, the client sends the service ticket D and an authenticator encrypted with the service session key G. The first service uses its long-term key to decrypt the first service ticket D and extract the service session key from that service ticket. This service session key is then used to decrypt the authenticator G and validate the user. As in our last session, there is an optional reply the service can send to the client, the KRB AP response, which contains an authenticator, this time encrypted with the service session key, shown as H in the diagram. When or if the client receives the service's authenticator H, it can use the service session key to decrypt the authenticator and so validate the service. Either after the optional KRB AP response or after sending the initial KRB AP request, the client sends the forwarded TGT F and an encrypted copy of the second TGS session key, shown as I, to the service in a KRB cred message. The TGS session key is encrypted using the service session key shared between the client and the service. Just as with the KRB AP request and response, this is most often wrapped inside the protocol used to connect to the service. Upon receiving the forwarded TGT, shown as F, and the encrypted TGS session key, I, the service uses the service session key to decrypt I and obtain the TGS session key. So now the service has the forwarded ticket granting ticket, shown as F, and the associated ticket granting service session key. For the first service to make a Kerberos connection to the second service, it needs to request a service ticket for the second service from the ticket granting service running on the KDC. So the first service sends a KRB TGS request containing the forwarded TGT F and a new authenticator J encrypted with the TGS session key associated with the forwarded ticket granting ticket. As before, the ticket granting service decrypts the ticket granting ticket, shown as F, using its long-term key. From this, it obtains the associated ticket granting service session key, which is then used to decrypt the authenticator and so validates the end user, but this time from the first service. The ticket granting service response, KRB TGS response, sent back to the service contains a service ticket for service 2, shown as L, and the second service session key encrypted with the ticket granting service session key from the forwarded ticket granting ticket, shown as K in the diagram. Upon receiving the KRB TGS response, Service 1 uses the ticket granting service session key it has to decrypt K, and from that extracts a session key associated with Service 2. So now the first service has the forwarded ticket granting ticket F and its associated ticket granting service session key, and the service ticket for the second service L and the session key associated with this service ticket. So in step 23, service 1 connects to service 2 by sending either a KRB AP request or by using the protocol used to connect to service 2. Contained in this request is the service ticket for service 2, shown as L, and a new authenticator encrypted with the service session key for service 2, shown as M in the diagram. For service 2 to validate the user, it takes the second service ticket, L, and decrypts it using its long-term key. This gives service 2 the session key for service 2, which is then used to decrypt the authenticator M, and so validate the user. As before, we have an optional step for service 2 to validate itself to service 1. For this to happen, service 2 can send an authenticator N, encrypted with the second service session key, back to service 1. Finally, service 1 uses the service 2 session key to decrypt the authenticator N, and so performs the optional validation of service 2. So we can see the process of Kerberos delegation or forwarding credentials is quite complex. And in this case, the first service now needs to be able to make the authentication request on behalf of the end user, and so make connections to the KDC. The second advanced topic we will address is cross-realm authentication. For cross-realm authentication, the client and server are in different Kerberos realms. Outside the process of authentication we will go through here, the administrators of the environment need to correctly configure a cross-realm trust for this process to work correctly. To start with, we have our standard 3 heads of Kerberos authentication: the client with the end user, the server running the service, and the KDC. For cross-realm authentication, we then have an additional KDC for our second Kerberos realm. As with the previous section on delegation, the initial authentication of the end user has already taken place. First, the Kerberos client makes a request to its defined KDC for a service ticket. This is the standard KRB TGS request message containing the ticket granting ticket B and an authenticator A encrypted with the TGS session key. As normal, the ticket granting service decrypts the ticket granting ticket B using its long-term key to extract the ticket granting service session key. The ticket granting service then uses the TGS session key to decrypt the authenticator A to validate the user. Now, the ticket granting service looks for the service principal name in the request and discovers that this SPN is not in its realm. So, the ticket granting service sends the reply KRB TGS response containing 2 items, C and D, where D is a ticket granting ticket for realm 2, including information about the client, and a ticket granting service session key for realm 2. This TGT is encrypted using the long-term key of the shared cross-realm principle. And C is the ticket granting service session key for realm 2, encrypted using the ticket granting service session key associated with the initial ticket granting ticket obtained by the client. The client decrypts C using its initial ticket granting service session key to obtain the TGS session key for realm 2. Now that the client has a TGT and associated ticket granting service session key valid for the second realm, it is able to create another KRB TGS request for the KDC in the second realm. This is shown in step 6 and contains the TGT for realm 2 and an authenticator encrypted using the TGS session key for realm 2. As we've seen previously, the ticket granting service, this time on the second KDC, takes the ticket granting ticket, uses the long-term key to decrypt the ticket and extract the session key. The difference here is that the long-term key used is associated with the cross-realm trust rather than the ticket granting service long-term key. Once the ticket granting service has the ticket granting service session key, it can decrypt the authenticator E and validate the user. The ticket granting service on the KDC in realm 2 sends the KRB TGS response to the client containing the service ticket F encrypted with the service long-term key and a service session key G encrypted with the cross-realm ticket granting service session key. Once the client receives the KRB TGS response, it takes the encrypted service session key G and decrypts this using the ticket granting service session key associated with the cross-realm ticket granting ticket, which gives the client access to the service session key. As before, the KRB AP request the client sends to the server most often is wrapped inside the protocol the client uses to connect to the server. Within this message is the service ticket from the KDC in realm 2, shown as F, and a new authenticator encrypted with the service session key, shown as H. The service goes through the standard steps to validate the user, namely taking the service ticket F and decrypting this with its long-term key to obtain the service session key. With the service session key, the service can then decrypt the authenticator H and validate the user. Then we show the optional KRB AP response, which contains an authenticator I encrypted with the service session key by the service and sent to the client. The client can then decrypt the authenticator I using the service session key to optionally validate the service. This completes the example of cross-realm authentication. The key parts of this setup are the cross-realm long-term keys shared by the two realms. The creation of these long-term keys is part of configuring the cross-realm trust we mentioned at the beginning. It's also worth noting the client needs to communicate with both the realms to correctly obtain the service ticket. If there are limitations on this network connectivity, cross-realm authentication is not going to work. This completes our review of advanced Kerberos authentication. For further information, you can see the following resources. To see details on the Kerberos Protocol version 5, you can review the RFC 4120 available here. And to look at the GSS API protocol, review RFC 4121, which you can find here. Finally, Microsoft have a guide explaining how Windows implements the Kerberos protocol, and that's available here. I hope you now have a better understanding of how the Kerberos tickets and encryption keys are used with these more advanced setups. By presenting these process diagrams, I think it makes these advanced setups clearer to follow and hence easier to troubleshoot any issues you might be having. Thank you, and check back with your Global Enablement and Learning team for more technical insight.